GeoGebra.org. This time you are going to go to GeoGebra Classic. Okay. Do you get the same thing I've got on the screen?
Yes.
Okay. You are then going to click on Spreadsheet. Click on Spreadsheet. That should open up a spreadsheet. You are then going to enter the data into a spreadsheet rather than the coordinates like we did before. That's where it's slightly different. So question 3 on page 224. I'm just going to type the numbers from the table. You can copy from mine or you can open your textbook. So the numbers are, right, I'm just going to put 2, 4, 7, 8, 10, 12, 13. And then I'm 13, 21, 29, 35, 44, 61, and 70. Okay. Now this is where some things might be slightly quicker and easier for us, where we can use the power of technology. There's a little quirk to this. I don't know why it's doing it. We've got to, these are going to be our coordinates of our point, right? What point do we need to add?
The mean point.
The mean point. So this is where it's quite useful. What you can do is highlight your x values and you can click on this sigma sign and you can ask it to work out the mean. Now this is where the quirk is. It gives me a 0, but don't worry about it. I'm going to do this one. Click on it, the mean, 39, that's a bit better. If I do the same thing again, it'll give me an answer. This time it's more appropriate. All right. Maybe you can tell me why it gives me a 0 first time around. I don't know. Maybe try doing the second column first. Or... All right. Got it? Got my mean point? So you can always label that the mean point if you like. It doesn't matter, just so we know. All right. Now what we need to do is put the points on the grid so we can see it. I'm going to go over here, settings like we've done before. I can change my grid size. I'm going to change it to 0 to 15, so I get in my 13, and the Y I'm going to change from 0 to what? 70. So let's put 72 in or something. Yeah. Press enter. I've got my grid. I can close that. I've got no points at the moment. Are you all with me at this stage? I don't want to go too much quicker. You've got your axes the same as mine. We can still drag it and see, it's fine. We can still zoom in and out, but it gives us a nice scale now. So I go up here, click on it, then click on the settings tab. And I put to fit these in. So my X values, I've gone from 0 up to 15 to fit my 13 in. All right, it has changed because I've rearranged my screen. But I could put 0 to 15, and then my Y was 0 up to 75. Right, that gives me my grid. Now I can still click and drag, but what happens after I reopen that, if I drag it around, the numbers will have changed, obviously. All right, but it doesn't matter because I just wanted it to be roughly in the right place. Okay. Have you all got the grid right?
Yeah.
Right, next thing then, highlight all of your numbers. Okay, got it? Then we're going to go to the 1, 2 in brackets, click on it, and you are going to create a list of points. If you click on that, call it what you like if you want, but you can see it's all there. I'm just going to click create, and you will see all the points appear. Got it? All right. Going to zoom out a little bit. So the way then that we can do our line of best fit by eye, can you notice something? Because this is something that you might not notice because it's a bit quick, and if you don't spot it, you don't see it. You're looking at my screen. If I click here, or if I click here, do you notice anything changes? The top, isn't it? So the tools change depending on what screen you're in. So I'm going to put on this here. So what? Oh, we'll sort it out afterwards. All right? Follow what you can. Now, if I click on the graph, I get this construction stuff, and this is where you can add another point. All right? Click on the point. I think, guess what that point's going to be? No, my mean point was already there. Yeah. Do you know where my mean point is? Well, my mean point is at 839, so it's this one, right? So when I'm in this, up here, look, click point. Okay, so now I've got my construction point. Okay, I think if you click on the point and click on that, you get the chance to change the color. All right, so I can call that red, so I know my mean point, again, I can change it to a different color if I like, so I know it's the mean point. The construction, same as before, look, if I click that point, but this time, click line, click that point, click the mean point, and I can do my, make sure I click on arrow to move, and then I can click, okay. Put it where you think. This is you're doing it by eye. Happy with that? Right. Everyone managed that all right?
No, I need to pause. Mine's still broken.
So the computer generated, I'm going to click on my spreadsheet one again. All right. I am going to highlight all those numbers. Now you'll notice there's no like construction point in there to worry about now. I am going to go to where it looks like a bar chart. Click on it. And which one do you think it is? So it's a regression analysis. And then a regression analysis is where you're trying to fit a function or a line to some points. So if we click on two variable regression analysis, you'll get another screen up. All right? With the same points. And this is our regression model. Now what we need to do is where it says none, which one do you think we could use?
Linear.
Right, why do you think there are other options there? In case you're thinking linear. Good. If it's a polynomial, that means it could be a quadratic or a cubic, or you're going to choose, or an exponential one or a sine. We can fit things to different curves. But we are going linear, so click linear. All right, and it will give you your actual one. Now, what do you also notice it gives you at the bottom?
Your equation.
The equation is already there, look. All right. I do believe as well, let me just try and remember. I didn't want that. There is a setting, you might be able to find it for yourself, that enables you to change. I did find it, I can't remember where it is now, from standard to, because this is in intercept and gradient form, right? But you can change it to standard form, all right? I'm going to close that one off. Now what we can do, all right, is we can, well, that's probably it. You can have a look. We can copy to the graphics view, okay? Or take it as a picture if you want to put it into your thing, okay? So what you then will do is you can compare your by eye model, all right? You can compare your by eye model to the one that was actually given to you, when it asks you to compare, and you can talk about that, you can put them side by side and say, right, what would the comparison, how good was I? Yeah. And then it will say, use your equation. Here's the equation for it. Does that make sense?
Can you help us with
In a sec. Right. So, of interesting things. So, just so you know, so you've got things to do in the future. Look at some of you like, I am looking. You're not the only one. This is a regression analysis, but we've done a linear one. Like I said, if you all click and do a polynomial, all right, it's a polynomial with a little 2 next to it. What does that mean? Squared. So it's a quadratic function I've tried to fit to my model. Now, what do you think of those? Do you think that's a better fit for that than a linear?
I do. I think so.
Can I ask you this then? How do I know if my line is a good fit, Steph? No, it doesn't have to pass through any, does it? No. That it could be miles apart and have an equal number on both sides. I've already told you this once. What do you reckon, Jay?
If it looks like that's what it should be like. It's a common sense.
I have given you, girls at the end, this is important, pay attention, I've already given you a method to decide how good I think my line is going to be. Ooh, am I 90% sure? Ooh, am I 80% sure? Desmond, have you got an answer? Or are you suck? No, they all have to pass through the mean point. Strength, and how do I find the strength? What is it? What was the letter? Did I give you a letter?
No.
Do you remember we did that example on the board where it was 90%, 80%, negative 90? No? You don't remember that starter where I asked you to put the lines and then we turned that? You had to click the same ones. The correlation coefficient, I said, between -1 and 1. 1 is when it's a perfect positive, and I can be 100% sure my line will give me a good prediction. If the correlation coefficient is only 80%, it's not as strong, yeah? So let me ask you this. Is this better than that? How would I know? Well, let's do this. Can you all go? I take it you've got one to look at. Go to your show statistics button. And what do you notice in this box?
Your mean X, your Y X, your S Y.
What's above P? R. R is the...
Radius.
No, it's not the radius. R is the letter that we call the correlation coefficient. YR, up to you to figure that out. But I have an R value of 95.5%. Okay? Is that a strong correlation?
Yes.
Yeah, 95%. It's saying it's pretty strong. Now, does it change anything? Let's just see. If I put in a polynomial,
No, it doesn't change. So they're the same.
all right? Well, let's just check. Is R affected by whether the line goes through it or not? So let's try an exponential.
It doesn't change.
Let's try a sine. Sine doesn't even work. Logistic, no. Let's do a
Growth.
logarithmic.
Do growth.
I think it's because you have to reload the thing.
Why? Other things are changing. R squared. Well, we can try it. Let's close that down. Let's change to polynomial. Still the same. Okay. Actually, R is how far in general points are away from the mean. Okay. So, but can you see how we could, like, if I change my order to a cubic, I can try and fit different models, or the computer will do it for me. Okay. So it's a good way. Now, when you are fitting a line to some data, it is called a regression analysis. For you at the moment, we're only worried about our linear ones. Yeah, that we can fit and we can get our equation. We've got our straight line. There's our equation we can use for prediction. But also, it's quite nice that we've got this R value. Right? So if you turn a couple of pages ahead in your textbook, all right, you will see where we start talking about that. All right. So, do you notice on practice 3 on page 229, we've kind of done this. It says assign a value for the correlation coefficient R to each graph in question. Okay. Justify your answers. So you would need to know, what values of R you might go with. All right. And then question 5 over the page, it says, what do you think the value of the correlation coefficient is? Justify your answer. Now we can find this on using technology. All right. Our correlation coefficient is a mathematical, it's a numerical value for the strength of the correlation. Okay.
So why don't they have it in percentage? Wouldn't it be?
Why? Because then I'd have to put a percentage symbol.
Then you would need a 0.
True. But why have one thing over another? It's how we interpret it. Because to turn this into a percentage, I have to do another mathematical step, like multiply by 100. And when you want to work with percentages, what do you have to do first? Well, if I want to find 95% of something, you don't multiply by 95 to find 95% of something, do you? You have to divide 95 by 100 to get you the decimal, and then you multiply by that, don't you? So actually, to work with percentages, we actually want the decimal value. But we can use our technology then to find our, and then for a question for some of you, you might want to consider, R squared is R squared. Right? Why would we want it? I'm not going to ask you to talk about that now, all right? But consider what would be the reasoning behind having an R squared value. What do you think it would do? Thinking about what R could be and then what R squared could be, all right? Why would we have an R squared? Anyway, I'll let you, you've got a couple more minutes. Try and finish off whatever question you're on.